Good day everyone and good day Sir Jermally. Today, we will discuss about internal combustion engine. But before that, I would like to introduce myself. My name is Dennis Pedida and right now I will discuss about the introduction of the internal combustion engine. So let's start with the heat engine. Heat engine is a device that converts the energy locked in fuel into force and motion. Fuels like coal, gasoline, natural gas, wood, peat, when burnt in an engine, release the energy it contains to power factory machinery and locomotives. As engine work by burning fuels to release heat, they are called heat engines. So right now, ito makikita natin yung diagram ng heat engine. So kung mapapansin natin, meron siyang dalawang classification. IC engines and EC engines. Under ng IC engines is rotary and reciprocating, the Wankel engine, open cycle gas turbine, gasoline engine, diesel engine. While the EC engine is under niya is reciprocating and rotary, steam engine, Stirling engine, steam turbine, closed cycle gas turbine. So by the way, yung IC pala is internal combustion engine, while yung EC naman is external combustion engine. So kung mapapansin nyo, doon sa IC engine, more on siya, mga tawag dito sa mga automotives. So yung mga engine na yan is ginagamit sa mga for transportation like mga kotse, mga sasakyan. While dun sa external combustion engine is madalas ginagamit siya sa mga power plant. Power plant. Okay, so dito naman mas natin i-define natin yung internal combustion engine. So ano nga ba si internal combustion engine? So from the word itself, internal, so yung combustion is nangyayari within the system, or basahin ko siya. So this process includes the combustion of a fuel that takes place within the system. These types of engine takes place where the fuel is burned in the engine or where the fusel fuel combustion occurs. Piston are mostly used in the internal combustion types of engines. So dito sa GIF, makikita natin yung process ng isang internal combustion engine. So sa process 1, so magkakaroon tayo ng intake ng fuel and then with air, kasama na yung air dito. And then yung piston natin is bababa. So and then sa process 2 is i-compress naman natin yung fuel and air. So yung piston natin is aangat siya until to the top dead center. So makikita nyo yung line na yan is yung top dead center. And then sa process 3, magkakaroon tayo ng combustion using the spark plug. So after nun, so bababa na ulit si piston, and then yung pang process 4 is yung exhaust. So aangat si piston and then ilalabas na si exhaust gas. So doon na lumalabas yung mga usok. So open si exhaust valve. So saka lalabas si exhaust gas. So ito ang tawag dito is exhaust valve, and then yung sa kabila is si intake valve. And then yung nasa gitna is spark plug. And then piston and then cylinder. Ayan. So next, ito, external combustion engine. So this type of heat engine takes where the fuel is burned outside the engine or where the fuel combustion occurs outside the engine. So from the word itself pa rin, external. So sa labas naman nangyayari yung combustion. It is a heat engine where a working fluid is included internally and heated by combustion in an external source through the engine wall. So kung mapapansin nyo dito sa example ko is yung makalumang tren na ginagamit dati. 'Di ba nilalagay natin siya ng ng coil or ng mga uling. And then susunugin yung uling na yon, tapos yung heat na puproduce ng pagsusunog ng coil is pupunta siya dun sa water, which is magiging steam yung water. Tapos yung steam na yun, siya yung magpapagalaw dun sa piston. Tapos from piston to crankshaft. And then yan, iikot na si gulong. Tapos yan, dire-diretso na siya hanggang matuloy-tuloy yung process. So ayun, nalalagay pa rin yung kung maupaubos na si coil, lalagyan ulit. Makikita natin sa mga dating palabas, no. Tapos ito, yung exhaust, dito siya lalabas sa pinaka tawag nila dito minsan is yung chimney. Yan. So or mga basta nilalabasan ng usok. Sige. So punta naman tayo sa comparison between IC and EC, or internal combustion and external combustion. So dito sa external combustion, yung fuel nga doon nga nag-takes place sa outside the engine, while doon sa internal combustion is inside the engine. So yun lang naman yung madaling intindihin, no. Pag external sa labas, pag internal sa loob. And then sa external combustion, kung mapapansin natin yung mga parts niya, merong boiler, merong piston, may cylinder, tapos yung lagayan mismo ng tubig, yung furnace, yan. Tapos yung pinaka chimney or yung labasan ng so mabigat siya. So heavy in weight. While dun sa sa internal combustion, cylinder, piston, tapos crankshaft, crankcase, tapos spark plug, mas magaan siya. So yun yung pinagkaiba nila in terms of weight. So next naman is efficiency. So sa efficiency ng internal combustion, mas mataas siya kaysa sa external combustion. So bakit? Explain natin, no? So dito sa internal combustion, dahil nga sa loob nagkakaroon ng combustion ng fuel, so yung heat energy is almost nagagamit lahat kasi nasa loob siya mismo. While dun sa external combustion, so susunugin pa natin siya sa labas. So gagamit tayo ng coil para magkaroon ng heat energy. So yung heat energy is yun, kalat-kalat siya, unlike dun sa internal combustion. So nasa loob siya mismo, mas puro siya. Kaya mas mataas yung efficiency ni external combustion, ni internal combustion. Yan. And then next is yung sa naman, pag restart niya. So less time required to start sa IC, and then sa EC naman, more time required to start. So madali siyang maintindihan kasi nga pag external combustion, susunog ka pa ng coil, while dun sa internal combustion kasi spark plug lang. So push lang ng button and then yun, magkakaroon na agad ng combustion or mag-start na agad siya. So dito naman regarding sa fuel or sa sa mga ginagamit. So sa internal combustion, mas mahal siya kasi yung mga ginagamit natin dyan is yung gasoline, mga diesel. While dun sa external combustion, ang ginagamit natin dyan is coil, tapos tubig. So mas mura siya in case of mga fuel. So yun yung report ko, and maraming salamat po.
I'm Rainier Edward Ramos, and we will now proceed to the classifications of internal combustion heat engines. We have two types of internal combustion heat engines, which is the reciprocating and the rotary heat engines. Reciprocating engine is an engine that uses one or more pistons in order to convert pressure into rotational motion. They use the reciprocating up and down motion of the pistons to translate this energy. Reciprocating engine have one or more pistons which follow the 4-stroke cycle visible in this figure. So in this figure we could see that To begin the cycle, it will first proceed to the intake phase, wherein a fluid, or in this example is a fuel mixture, is induced inside the cylinder through the intake port, expanding the piston to the bottom of the cylinder. Next is the compression. The piston then gets pushed to the top, compressing the fuel mixture and igniting it via the spark plug. Next is the ignition, which pushes the piston downwards, providing useful work to the engine. Then lastly, the exhaust, where the waste chemicals get output through the exhaust port and the cycle repeats. The 4-stroke cycle is what gives the engine its energy. But now, it must translate this energy into rotational energy for the transmission, drive shaft, and wheels. This is done by the crankshaft, which is seen in this next figure. The crankshaft converts this up and down motion into rotational motion, which is often combined with the flywheel to retain the discontinuous reciprocating energy as rotational energy, like what you see in this figure. So next type is we have the rotary engine. So rotary engine is the type of internal combustion engine which converts heat from the combustion of a high fuel or air mixture into useful work. Its unique characteristic is its rotor, which provides the same task as a reciprocating engine's piston would, but in a different matter. So in this figure, we could see the Wankel engine, which is another type of rotary engines here in this figure. So like the reciprocating engine, it also uses 4 stages of the cycle, but in different ways. So first is the intake. So here in this sample figure, the intake initiates when the tip of the rotor passes the intake port. At this moment, the chamber is at its smallest, and as it rotates, the chamber expands, drawing in the air-fuel mixture. As soon as the rotor end passes the intake port, it moves onto the compression stage, while the next phase of the rotor starts the step over. Next is the compression, wherein as the rotor continues spinning, the air-fuel mixture becomes compressed because the chamber is decreasing in size. This is necessary for the next part, which ignites the mixture. In the ignition process, the compressed mixture gets ignited by spark plugs, and the vast increase in pressure forces the rotor to expand. This is the power stroke, providing useful work. 2 spark plugs are often needed to provide even ignition throughout the chamber. The exhaust gas expands into the chamber until the rotor tip passes the exhaust port. Then lastly, the exhaust process wherein once the tip passes this port, the high pressure exhaust gases can flow through the exhaust port. The rotor continues to spin until the end of its phase passes the exhaust port, the tip passes the intake port, and the cycle repeats. Besides the different method to complete the 4-stroke cycle, rotary engines have different advantages and drawbacks from the more common reciprocating engine. The difference from a reciprocating engine is rotary engine has few moving parts, 2 rotors and an output shaft, while ordinary reciprocating engine have at least 40. This gives rotary engines better reliability. Rotary engine is smoother since the rotor spins constantly in one direction, unlike reciprocating engines whose pistons change direction abruptly. They are also counterbalanced by weights which reduce internal vibration. The power delivery is also more continuous because of the 3 power strokes for every turn of the rotor. And lastly, rotary engine is slower because the rotor spins at 1/3 the speed of the output shaft. So the main moving parts move slower than those in a piston engine, which improves reliability. But the only drawback of rotary engine compared to reciprocating engine is that the manufacturing costs can be higher due to the lower popularity of these engines. They also typically consume more fuel than any other engines due to their low compression ratio and therefore have a low thermal efficiency, which makes it difficult for them to meet emissions regulations. These two kinds of engine has another types also which will be discussed by the next reporter. And these different types of these engines are using different kinds of fluids to produce these energies that work rather. So these types of engines uses different types of fluid to produce a necessary useful work.
Okay, good day everyone. Ako nga pala si Juno Ragoro at ang topic na i-discuss ko is all about open cycle gas turbine. Open cycle gas turbine is sa process na ginagamit sa internal combustion engine upang makapag-create ng work galing sa heat energy. So ano nga ba yung principle na ginagamit sa open cycle gas turbine? The open cycle gas turbine operates on the principle of drawing the fresh atmospheric air at ambient conditions into the compressor where the air is compressed. The compressed air at the higher pressure is fed into a combustion chamber where the fuel will be burned at an essentially constant pressure. The high pressure hot gases drive the turbine and develop power owing to the rotation of the turbine shaft. The exhaust gases that leave the turbine are released into the atmosphere. So yun, para mas maintindihan natin is tignan natin tong schematic diagram. Meron tayong compressor at combustion chamber na tinatawag na kung saan nandito yung spark plug natin at yung pinaka-turbine natin. So mag-umpisa tayo sa compressor. Once na pumasok yung fresh air natin, the compressor will compress the air para maging high pressure siya papunta sa combustion chamber at mag-i-inject ng fuel si combustion chamber. At once na nag-inject siya, kagana si spark plug upang gumawa ng ignition. At pag nag-ignite siya is magkakaroon ng combustion. Once na nagkaroon ng combustion, magkakaroon tayo ng high pressure hot gas upang pumunta sa turbine natin at paikutin ito. At yung mga excess na air natin nun is itatapon niya sa ating exhaust. Yung mga excess air na yon is kadalasan yung mga usok na nakikita natin. So yun, the cycle is classified as an open cycle system since the exhaust gases are not recirculated but released into the atmosphere. So ang open cycle gas turbine pala is makikita natin na ang ginagamit niyang medium is yung air, na kung saan pag nakaisang cycle na si air, itatapon niya to at kukuha ulit ng panibagong air. So yun si open cycle. So ito yung cross-sectional view nung ating gas turbine. meron siyang compressor, combustion chamber, at si turbine. So yun, makikita natin dito. Pumasok si air, papunta kay compressor. At once na-compress niya na papunta kay combustion chamber, nag-inject siya ng fuel. At pagka-inject niya, nagkaroon ng combustion, papunta ulit kay turbine na siyang iikot. At yun, may lumabas na exhaust. Okay, dito may video akong papakita kung anong itsura niya pagka nangyayari yung combustion. So yun, nakikita nyo na pumapasok na yung air at nung pumunta siya sa combustion chamber, nag-inject siya ng fuel. Pagka-inject niya ng fuel is nagkaroon ng combustion na siyang nagpaikot dun sa ating turbine. So yun, isa sa mga application nga pala nito is yung mga engine natin like sa mga aircraft. Yun, mga ganun. So yun lang po yung topic na i-discuss ko. Maraming salamat.
I am King Manuel Pacetes and I am here to discuss to you the Wankel engine, the second type of the rotary engine. First of all, what is a Wankel engine? Wankel engine is a type of internal combustion engine distinguished by an orbiting triangular rotor that functions as a piston. It is invented by a German engineer, Felix Wankel, in 1951. It was first tested for use in automobiles in 1956. Let's now talk about first the parts of the Wankel engine. The first one is the intake port. It is the entry point for the gas into the engine. The next one is the output shaft that moves the rotational kinetic energy from the rotor to the rest of the car. The next one is the triangular rotor that divides the chamber into intake, compression, and combustion areas and supports the energy of the system and the engine's gear set. The next one is the spark plug. Spark plug provides electric energy used to combust the compressed fuel. The next one is the housing. The housing contains a combustion reaction and guides the motion of the triangular rotor. The next one is the fixed gear. The fixed gear attached to the housing to ensure the correct movement of the rotor within the housing. Then the last one is the outlet port, and it is the exit area for ignited gasoline. So how does a Wankel engine work? The engine functions in a four-step process: the intake, the compression, the ignition, and the exhaust. First, the intake. During this phase, a drop in pressure caused by the rotor's motion draws in an air-fuel mixture. This mixture is thrown around the rotor and forced into the second stroke of the cycle. In order to ensure that none of the exhaust from the previous cycle re-enters during intake, the housing is extended to touch the edge of the rotor. So, the next one is the compression. In this phase, the rotor forces the mixture into a tighter area of the housing, creating a pressurized air-fuel mixture. It is important that the fuel be compacted at this stage because it will not ignite if it is not at the correct pressure. Taking the compressed mixture from the previous stroke, the third stroke ignition ignites the mixture, creating the exhaust and the energy used to move the rotor. To compensate for the odd area needed to contour to the shape and position of the rotor at this point, the spark plug needs to be positioned in a way to ensure the mixture burns evenly. This is the most important stage in the cycle because it determines the speed and power outputted by the engine. The fourth and the final stroke of the Wankel engine process is the expulsion of the exhaust through the outlet port. The sudden expansion of the now gaseous fuel mixture forces the rotor back around to its initial position. The exhaust is thrown from the engine to the exhaust system of the car. And for the application of the Wankel engine, it is currently used in a motorcycle, race cars, airplanes, and even go-karts. And that's all for the Wankel engine. Thank you.
Hi guys, so ako yung magdi-discuss ng gasoline engine. Disclaimer lang, pasensya na sa mga wrong pronunciation. Hindi ako talaga magaling dyan. And sorry din sa tahol ng asa ko kung tatahol siya man. Papansin kasi yun eh. So, back to the topic. First, what is gasoline engine? Gasoline engine is a type of heat engine, specifically an internal combustion that is powered by a gasoline. Or in other term, it is an engine that generates power by burning a volatile liquid fuel. Example niyan is gasoline mixture, and ethanol, etc. With ignition initiated by an electric spark. So, ayun lang yung pinaka-main concept or yung pinaka-main definition ng gasoline engine. So guys, ang i-discuss ko lang pala is yung function and application lang ng gasoline engine. Next slide, makikita nyo dito yung image or example ng isang gasoline engine. Alam ko medyo may background na kayo or familiar na kayo dyan kasi may mga past subjects na tayo nadaanan yan, and some of our classmates are working in the automobile industry. Kaya alam ko sobrang gamay na nila or familiar na sila sa itsura na yan. Next, gasoline engine can be grouped into a number of types depending on several criteria, including their application, methods of fuel management, ignition, piston and cylinder or rotor arrangement, strokes per cycle, cooling system, and valve type and location. In this section, they are described within the context of two basic engine types. Ano yun? So, una is yung piston and cylinder engine and rotary engine. First, let's define what is piston and cylinder engine. The pressure produced by a combustion of gasoline creates a force on the head of the piston that moves the length of the cylinder in a reciprocating or back and forth motion. This force drives the piston away from the head of the cylinders and performs work. While yung rotary engines, also known as Wankel engines, does not have a conventional cylinders fitted with the reciprocating piston. Instead, the gas pressure acts on the surface of a rotor, causing the rotor to turn and thus perform the work. So mamaya magpapakita ko ng images para mas visualize nyo or intindihan nyo kung ano yung sinasabi ko. Next slide. So in the left side, makikita nyo yung piston and cylinder engine, and yung sa right side naman makikita nyo yung rotary engine. So dito muna tayo sa piston and cylinder engine. So piston and cylinder engine has two types of cycle. First type is yung four-stroke cycle, and the second type is yung two-stroke cycle. So first, let's define what is four-stroke cycle. Four-stroke cycle in which the piston completes four separate strokes while turning the crankshaft. A stroke refers to the full travel of the piston along the cylinder in either direction. The four separate strokes are termed intake, compression, power or combustion rather, and exhaust. So dito muna tayo sa intake. In this stroke, the intake valve must be in an open position where the piston pulls an air-fuel mixture in the cylinder by producing vacuum pressure in the cylinder through its downward motion. The piston is moving down as the air is being sucked in by the downward motion against the piston. So, yung half rotation or yung 180 degrees na crankshaft, bababa yung connecting rod, which means bababa din yung piston. So, due its downward motion, magkakaroon siya ng vacuum pressure. So, papasok, since open yung intake valve natin, papasok yung air-fuel mixture. Then, the next 180 degrees ay naman yung compression. In this stroke, the piston compresses the air-fuel mixture in preparation for ignition. Both the intake and exhaust valves are closed during in this stage pala. So nakapag-kompleto na tayo ng isang 360, so nagkaroon na ng isang revolution yung crankshaft natin. The next 180 degrees, which is yung start na ng second revolution ng crankshaft natin, ay na yung combustion or power. In this stroke, the compressed air fuel mixture is ignited by the spark plug. And the next 180 degrees, which is yung panapos natin sa second revolution, which is yung exhaust. So mag-open yung exhaust valve, and this action expels the spent air fuel mixture through the exhaust valve. So lalabas na yung exhaust air or exhaust gases natin dun sa cylinder. So next slide, mas visualize nyo dito kung paano ba yung strokes na yon. So mas kita dito kung paano yung intake, compression, ignition, and yung exhaust. Then dito naman tayo sa two-stroke cycle. So ano naman yung pinagkaiba ng two-stroke cycle sa four-stroke cycle? So two-stroke cycle or two-stroke engine is a type of internal combustion engine that completes a power cycle with a two-stroke of the piston during one crankshaft revolution. So kanina sa four-stroke engine, dalawang crankshaft revolution yon. So dito naman is since two-stroke lang, so isang crankshaft revolution lang. In a two-stroke engine, the end of the combustion stroke and the beginning of the compression stroke happen simultaneously with the intake and exhaust function occurring at the same time. So unlike kanina, iba pa yung stroke ng intake, ng compression, ng combustion, and yung exhaust. Dito, sabay yung combustion and compression, and yung intake tsaka yung exhaust. So next slide, mas makikita nyo. So pansin nyo dyan, yung combustion and yung intake sabay siya sa isang kalahating ikot yan ng crankshaft. Then yung exhaust tsaka yung intake, sabay din siya. Ayun naman yung pangalawang crankshaft. Another key difference between engine designs is that two-stroke engines are less expensive to build, lighter, and offer a high power-to-weight ratio than four-stroke engines. For these reasons, two-stroke engines are ideal in handheld applications like chainsaws, string trimmers, and backpack blowers. Two-stroke engines are also easier to start in cold temperatures. On the other hand, four-stroke engines produce more torque at lower RPM, generally provided a greater equipment durability than high reviving two-stroke engines, and also provide better fuel efficiency and lower emissions. For these reasons, four-stroke engines are ideal in applications such as motorcycles, ATVs or UTVs, marine motors, and personal watercraft.
Good day. I am Candice Peña, and from this group, I will be discussing the definition of diesel, how each stroke is about to happen, its application, and also their functions. But firstly, how does diesel really make? We all know that we need to choose a cost-effective fuel to meet our needs. That's why, thanks to Rodolph Diesel, who invented the diesel, which has proved to be the extremely efficient and cost-effective. In internal combustion engine, which they call IC engine, it transforms the chemical energy in the fuel to mechanical energy. Diesel engines, which would be serving mankind for over a century, are the most versatile and economical IC engine. To release the mechanical energy, this diesel effectively, the form of the fuel has made contact on high temperature and high pressure air, and this energy is effectively transferred as mechanical rotational energy. So the operation of diesel engine is all about using high temperature and of course high pressure air continuously. On this slide, we will see how it is achieved by showing the short animation that we provided. We all know that piston is connecting to rod, crank, and cylinder, or what they call a kind of mechanism, which is the slider crank mechanism. Here, the linear motion of the piston transforms into rotary motion of the crank. In IC engine, this mechanism is properly supported in an engine block, cylinder head, valve, and fuel injector which are fitted above in engine block. When the piston moves downward, of course, the inlet valve opens and fresh air outside is sucked, or in other words, the engine breathes. Yes, it is. The engine is breathing. And during these stages, which they return the stroke, inlet exhaust valve are closed and air inside the cylinder gives compress. On the second stages, during the compression stroke, the stroke of the piston does work on the air. That's why the temperature and the pressure of the air will rise to a level which is higher than the ignition value of the diesel. A form of diesel is injected in a compressed air that the fuel gets evaporated and undergoes an uncontrolled, spontaneous explosion. As a result, the pressure and temperature rise the high level value. On the third stages, the high energy fluid pushes the distant downward. The hot air does work on a distant in energy fluid, which converted and transformed into mechanical energy of the piston. This is the only stroke where the piston absorbs power from the fluid, and due to inertia of the system, it moves upward again, and this time the exhaust valve opens, which is the last stages, and the exhausting rejected. Again, the second strokes happen. This cycle, which has a total of 4 strokes, is repeated over and over for the continuous power production, from suction to compression to power and to exhaust. You may have noticed that a bowl is provided on the top of the diesel engine piston, and during this compression stroke, this bowl really helps to produce air that is rapidly swirling. Thus, the injected fuel gives mix with the air effectively. This kind of mechanical design of an IC engine is a very challenging and interesting path, since we all know that the combustion process and diesel engine is never uniform and smooth. They add an additional idea wherein they made a 4-cycle cylinder stroke, which has happened to be a good idea indeed, where every stage is about to move every time. It would help better force, better power, uniformity. In short, the more cylinder it has, the smoother it is. For additional idea, it provided heavy flywheel in order to support the non-uniformity of the power. Now that we know the process, let's proceed to the advantages of diesel engine to our today's modern world. First, one thing what good is that they have overcome the disadvantage of earlier models of higher noise and maintenance. Because of what I said earlier, we have already a 4-cylinder stroke, which is made for now as a quiet and less maintenance as compared with gas engines of similar size. Second, they are more rugged and reliable. Why? Because it is used compression which build more withstand the higher compression, which means better longevity. For they really made for the environment because of being fuel sufficient and emit less carbon dioxide. Third, number 3, there's no sparking as the fuel auto-ignites. The advantage of the absence of the spark plugs or spark wires, it lowers the maintenance cost. And the last, fuel cost per kilowatts produced is 30 to 50% lower than gas engines. So yeah, very eco-friendly. Next topic is let's go to the application of the diesel engine. Obviously, indeed, that everywhere I observed on my daily basis, if I were to look under the hood of everything I pass by, diesel engine will always be might involved everywhere. To name a few, it is commonly used for locomotives, automobiles, construction equipment, and industrial applications. Next is why power generation is the major application of diesel engine. To make it short, it is because industrial diesel engines and diesel-powered generators have constructions, marine, mining, hospitals, forestry, telecommunications, underground, and agricultural applications. Those are larger loads that covers a power rating from 30 kilowatts and 6 megawatts. However, if you want to keep a power generator at home, you can use it as a standby or backup power sources for small loads typically rating from 5 to 30 kilowatts, which for personal applications only. So yeah, that's I hope I hope that I shared a lot of information about diesel engine. Thank you.